In section 5, we are going to move on from calculating the concentration of a solution to what happens if you want to dilute the solution. Most of you probably know that water can be added to a concentrated solution in order to make it, well, quite frankly, dilute, to make it so that there's the same amount. When it says that there's no change in the particles, they're talking about the solute. So the stuff we added to it doesn't actually change. The amount of moles doesn't change. What does change, however, is the total solution. Because the total solution is the solute and the solvent added together. And what we're doing is we're adding more solvent. So this number on the bottom is increasing, which is making the total number go down. We didn't touch the solute, we only touched the solvent. So in a dilution, you add the water, the volume goes up, which then actually makes that, so if we look at, for instance, molarity, it's moles over liters. The volume on the bottom is increasing, which when we divide those two, the total number decreases. And that's going to be the same with any kind of percents as well. So if we have a percent by mass, that means grams of the solute over the grams of solute added to the grams of solvent. We didn't touch the solvent, we're adding water. We're adding this, the solvent. So in the process, when we divide that, this number on the bottom here is still getting larger, which means when we divide, the whole number will be smaller. Once again, the mass of the solute, the amount of solute you have there is always going to stay the same. As a real world example, let's say you're making concentrated orange juice. Orange juice from concentrate. You have a frozen can, and then you add 3 cups of water. However, you didn't add any more of the orange juice. The amount of orange juice you had there at the beginning is still there. It's just dilute because you added more water. So this is the equations we use to figure out what the final molarities be, how much volume you need at the beginning. This has actually several different purposes. Notice the 1s and the 2s. This is the initial. C means concentration. So the concentration of the solution initially before you add any more water. The volume of the solution before we add any water. And this is after we've diluted it. So we have a new concentration and we have a new volume. One thing you want to make sure of is that all the units cancel out. So if we have one volume in milliliters, we need both of them in milliliters. If we have one volume in liters, we need both of them in liters. It really doesn't matter which unit it is as long as they're the same. And so M on the next equation is molarity. So the molarity before we diluted it, the initial one. And V1 would be the volume. And then once again over here, on the right hand side of the equation, is after you've added the water. So there's really no other way to do this except to go ahead and start doing practice problems. So that's what we're going to do next. The final concentration, what is the final concentration? So we are looking for C2. That is our question. When 0.5 liters of 6 molar HCl, so that is our V1, that is our C1. You have to be very careful of where our units or what variable goes with what numbers. Notice this of in there. That links these two things together. So that means that that 0.5 and that 6.0 have to be on the same side of the equation. Since I'm seeing M here, even though it says concentration here, concentration is a generic term. It's for percentage and for molarity. So I'm going to change that C2 to an M2 and the C1 to an M1. All because I see the big M. In all reality, if we compare the two equations, they're exactly identical. You're just replacing the M with a C. Okay, so let's go back to the question. What is the final concentration when 0.5 liters of 6.0 molar HCl is diluted to a final volume, there's another clue, of 1 liter, so that's going to be our V2. So, we have M1, V1, M2, V2. M1 is 6.0 molar, V1 is 0.50 liters, M2 is our X, V2 is 1.0 liters. So 6.0 molar times 0.50 liters is equal to X times 1.0 liters. Notice 0.5 liters of 6.0 molar, those have to be on the same side of the equation. If we look down at our equation, 6.0 and 0.5, they are on the same side of the equation. That's good. So we have we multiply those together, it gets 3.0 moles per liter, molarity times liters is equal to 1.0 liters X. We're going to divide by 1.0 liters. The liters cancel. Liters over here cancel. So 3.0 divided by 1 is 3.0. And we're left over with molar. Alright, let's do another one. Now we're looking at percentages. Percent here automatically means I'm looking at C's rather than M's. Once again, not really that relevant because it's the exact same equation with different letters. What volume of, so we're looking for a volume of 2%, notice the of, that means the question and this percentage is going to go on the same side of the equation, of 2.00% HCl solution can be prepared by diluting. So we're diluting this of this. So that's going to be V1. That's going to be C1 because that's what we're diluting. This is going to be C2, which makes this one V2. So C1, V1, C2, V2. C1 is 14%. V1 is 25.0 milliliters. C2 is 2.00%. And V2 is our X. So 14.0% times 25.0 milliliters is equal to 2.00% times X. All I did was take these numbers on the left-hand side and put them into the equation. C1 V1 is equal to C2 V2. So 14 times 25 350% times milliliters is equal to 2.00% X. So 2.00%. Left side cancels and left with X. So, and the percents here cancel. So we have 350 divided by 2. It becomes 175 milliliters. So, if you dilute 25 milliliters of 14% to get 2%, you'll have 175 milliliters when you're done. The volume went from 25 to 175. Okay, what is the percent? So once again, we're looking for C's. Our equation is going to be C1V1 is equal to C2V2. What is the percent of a solution prepared by diluting, notice this of here, 10 milliliters, so that's going to be our V1, 9% is going to be our C1. By diluting, that's telling me that this is our initial thing. Also, it's the smaller of the two numbers. If we look at milliliters and milliliters, we compare the two. Because this is smaller, it's the first one. The bigger one is the 2's. The reverse is true with the percentages. So the percentage actually goes down on the two sides. So, by diluting 10 milliliters of 9.00% in AOH to 60 milliliters, that's going to be our V2. Notice it didn't say a volume of 6 milliliters. You should know that milliliters means volume. So, that means this is going to be our C2 up here. What percent of a solution prepared by diluting? So that's going to be, they want to know what our final concentration is. So C1 is 9.00%. V1 is 10.0 milliliters. C2 is going to be our X, because that's what we're looking for. And V2 is 60 milliliters. Alright, so now we just plug the numbers in. 9.00% times 10.0 milliliters is equal to X times 60 milliliters. So, multiply across, so 9 times 10, that would be 90%. That milliliters is equal to X milliliters. Divide both sides by 60 milliliters. The right side cancels, so 90 divided by 60. We want three significant figures, so 1.50% is equal to X. Alright, we're back to molarity. So that means we're using M1, V1 is equal to M2, V2. What is the molarity of a solution prepared by diluting? So this is going to be our initial ones because that's what we're starting with. Also notice that the volume goes up. So the smaller volume is going to be the initial one. Liters, they don't tell you what that is the volume, but you should know that that's the volume because of the fact that it says liters. And that's going to be your C1. Notice the of connects these two together. I can't reinforce that enough because most people get lost as to what are ones and what are twos. The word of connects those to the same side of the equation. 0.540 liters, that's going to be our V2. This must be our M2 then. M1 is 0.600 molar. V1 is 0.180 liters. M2 is our X, and V2 is 0.540 liters. So M1V1 is equal to M2V2. So that means 0.600 molar, 0.180 liters is equal to X times 0.540 liters. multiply these two together. So 0.6 times 0.18 is 0.108 moles dot liters, because those don't cancel. Divide both sides by 0.540 liters. The liters cancel, so we're going to be left over with molar. And we want three significant figures because that's how many are in our question. 0.200 molar is going to be our final concentration. Notice that when we diluted it, the concentration went down, but the volume went up. Okay, and that is all for dilutions. I hope you understood that thoroughly.